about some space weather. Like looking at the sun in 171 angstroms. We've made a custom animation here to zoom in on this active region. Not to be confused with a sunspot. It's a pretty good view here. Let's look at other views. And here's the 193 angstroms view. We see a coronal hole rotating out of the Earth-facing area there in front of that active region. Kind of just center right solar disk. And there are the magnetic field lines. And we'll head to Space Weather Enthusiast dashboard to look at the WSA Enlil prediction. Let's make that a smaller size. There we go. So we don't really see any solar wind streams in the forecast. There's a density increase predicted on the 19th. But until then, you should see weak solar winds. So here's a real-time solar wind. And we see the BTBZ is now jumping around a little bit. And the phi angle has had what you'd call like a flirtatious relationship with the 180 line there. And there was indeed an earthquake uptick. There was a 6.4 yesterday. We're not going to cover that. It was too long ago. But yeah, so there's an earthquake uptick. We'll cover that in a minute. Solar wind density up to 9.17 protons per cubic centimeter. Oh, and by the way, it looks like there's currently a coronal hole connection. See that little signal right there at the end? Very close to the 180 line, indicating a sun to earth magneto-hydrodynamic flow. Solar wind speed is at 354 kilometers per second, moving on. 10.7 centimeter radial flux has dropped back down to 70, still higher than predictions. Look at some other data here, spaceweathernews.com. We see the X-ray flux is flatlined. And we see these big perturbations in the magnetometer. Check it out. We'll be looking at the gong too in a minute to see what's going on with that. I think you'll find it interesting. Crossing of the heliospheric current sheet again. And yeah, KP is up to 3. Here's your electron flux. See a dip in that. You have some charging hazards over northern South America. Nothing too extreme. F2 layer looking fairly normal. Aurora forecast looking normal. Here's the total electron content forecast. You do see a little bit of anomalous electron flow there, heading up toward, let's see, where is that? Right across the northern US. And then kind of going across Alaska and then just vanishing before getting to Asia. Little electron spike in that area. Probably causing a little bit of GPS failures, like the one I had yesterday when I was trying to log a run. Next, we'll take a look at magnetosphere movies. We see some extreme low velocity there near the magnetotail. You see that dark red? That's a low velocity zone. And then it looks like it's equaled out a little bit, normalized. Here's the density. And at least we have all 4 hours of data today. The equatorial plane view is looking very choppy at the beginning there. That is a very odd thing. Check it out. It's usually a lot rounder than that, indicating some sort of magnetic disturbance. And it looks like it's smoothing out there. And here's the pressure. A lot more normal than the last 2 days, as we've seen a slight increase in the solar wind. Next, we'll look at geomagnetic ground perturbations over the poles. See a little bit of jumping around on the north side there. And the standard Indian Ocean South Pole bleed that we see every day. Here it is on the global scale. Some strong fields leaking down there into Canada and Greenland, also into the Pacific Ocean. And the standard South Pole into the Indian Ocean, excuse me, which is what we've been seeing lately. We'll let that play through one more time. I think we need more data right here. Now we'll look at quakes.globalincidentmap.com. We're going to bypass the 6.4 that happened yesterday. I believe that was in Papua New Guinea. We're just going to look at the last, well, we'll go all the way back 15 hours. So we see a 4.4 in Russia, and we see a 4.7 in the Fiji region at 594 kilometers depth. Super deep quake. We also see antipode quakes on the opposite side of the planet. Right around the same time, like about an hour later there, we see one in Greece. And then another deep quake in Fiji. That's a little bit unsettling, folks. There's a Greek quake. Magnitude 4.8. And then another quake in Fiji, as if the force is bouncing back and forth through the center of the planet. The Philippines receive a 4.7 at depth. So we're still looking at the possibility of a coronal hole to Earth magnetic connection. And that earthquake watch just continues on and on. 4.6 in Indonesia. 5.1 in the South Sandwich Islands. Another type of quake that used to be very rare. And now we're seeing these quakes very far south like this. Practically Antarctican. .1 at Japan, and a 4.5 at Japan, and another 4.5 at Japan, and those are, that's one quake, folks. It happened at the same time. It looks like the quake started out at nearly 500 kilometers and ended at 489 kilometers. So they, that's an indication to stay on alert. But they're in the alert area anyway. All right, so there's 4.5 in Kamchatka, 4.7 in Mexico, 4.8 in Alaska, and a 4.9 in Alaska at nearly 200 kilometers depth, placing Alaska on alert. Well, this is the Aleutians. There's really nobody there, but lots of activity in that region. Also a 4.2 in Japan at 422 kilometers depth. And what does it all mean? What it means is that if you're in this area, or this area, or this area, you need to have a disaster plan. Just realizing that there could be a disaster is a hell of a lot better plan than having no idea. I mean, the first thing you want to do is put together a bug out bag, I mean, have some food in there, a day's worth of food, water, any medications you'd need, shoes, and have it by the door. Flashlight, your basic stuff. Maybe a hand crank radio, maybe a cell phone charger. Go outside your door, look up, see if there's anything that's going to fall on your head during an earthquake when you try to exit the building. Little things like that can save your life, people. So do it. Speaking of disasters, let's look at volcanodiscovery.com as we see some new entries on the list. Etna is back to explosive activity at the northeast crater, not producing a large plume, but nonetheless back to erupting. Karimsky, producing a 10,000-foot plume now, so that's back on the list. Krakatoa remains eruptive, but it looks like it's calming down a bit, producing only a 2,000-foot ash plume. Tukono, 7,000-foot volcanic ash plume there. Popocatépetl, still erupting heavily with a 21,000-foot ash plume. Sabancaya, sporadic puffs of volcanic ash. Planchon Peteroa, volcanic ash not identifiable from satellite. And Piton de la Fournaise at Réunion Island started to erupt. So that's a new one on the list also. Moving on. Now we'll look at the Gong 2 here, the line of sight field plot, so we can kind of explain what's going on with the solar magnetic fields. And pretty much what's happening here is all because of this active region. We have the north Z field, which is this, and the south Z field, which is this. They're playing tug of war over this active region, or you could say the active region's playing tug of war on their fields. And that's why the B field, which is this blue portion, is swinging up and down the way it is, creating different charges in the current sheet. Let's look at it from a different view, because it's a little easier to understand. At least easier to, geographically understand. Top view, ecliptic plane field plot. There you go. You can see there's going to be another crossing of the current sheet there. And the magnetic instability is associated with this. It's pretty much entirely because of that active region. Let's just look at the last frame here. Now you can see at any time the Earth's field is going to snap across. It's going to do some number like this. And let's see. Will we see a spike in the magnetometer? There should be a spike. There should be some perturbations. In fact, we already see it going on. So study the GOES magnetometer all day if you want to see when this occurs. Keep in mind the data here is 1 hour and 44 minutes old. Next, we'll look at Zooniverse.org, one of the largest citizen science projects in the world. What's that all about? Well, it's called Galaxy Zoo. And we want you to classify galaxies. There's still several million left, so you better hurry up because the planet has like 7 billion people on it. In any case, set yourself a login, head to the Galaxy Zoo portion of the Zooniverse.org site, and classify a galaxy, like this one. So, I'm going to say I see features. Is it an edge on disk? Not really. Is there a bar? No, there's no bar. No bar. Is there a spiral arm pattern? No apparent spiral arm pattern. Is there a bulge? Well, there sure is. I'm going to call that, let's see, we're going to call that a large bulge. Is the galaxy merging or disturbed? I think there is a minor disturbance there, up in this region. So we're going to say minor disturbance. Do we see any unusual features? Possible overlap, which you will see in a lot of galaxies. And there you go, we just classified a galaxy. Will you be the citizen astronomer to classify this galaxy? Galaxy Zoo at zooniverse.org. Interesting article on Science Alert about the human brain. By the way, I was a psychology major for a while. About a year and a half. I took 83% of the core classes in psychology, and then I got the hell out of there. Neuroscientists say they found an entirely new form of neural communication. Scientists think they've identified a previously unknown form of neural communication that self-propagates across brain tissue and can leap wirelessly from neurons in one section of brain tissue to the other, even if they've been surgically severed. Let that sink in. That's not what we call synaptic transport or axonal transport. It's not a gap junction connection. How is it done? Well, they don't know how it works. But it's interesting nonetheless, and so is the article. So we'll leave you a link. By the way, also, I would note the similarity between human neural tissue and the galactic cosmic web. Not the galactic cosmic web, the intergalactic cosmic web. Speaking of cosmic webs, we're going to look at some cosmic ray stations here. We'll leave links to this also. Check out what's going on at Athens. They had to totally change their scale because their monitor is showing crazy data. A 26% reduction, and then a 10% increase of that. So, not sure what's going on there. If anybody would like to contact the Athens Neutron monitor and ask them what's going on with their data, we would appreciate it. Next, we'll look at Mexico City, which does not agree at all with the Athens monitor. There's Mexico City. Here's Moscow. Showing a little spike yesterday. Again, nothing like Athens, though. And here's Oulu, Finland. DOMC Antarctica. And there's DOMB Antarctica. Moving on. Check out random-eyes.com. You want to see a random website? Do you? Do you? Do you want to see a random website? Do you dare me? Do you dare me? All right, here we go. StuffOnMyCat.com. Check it out. Groundbreaking material here. Stuff on my cat. All right, we got sunglasses on the cat. We got, what is this? Some kind of gifts or something on the cat. You got Christmas lights on the cat. You got a whoopee on the cat. Great. Wonderful. Wonderful. A sock. Very, very imaginative. A dress. A series of office supplies. How about some remotes, a glass of water, and some glasses? What a sight. Man, I could surf this all day. What about you? StuffOnMyCat.com. Oh, look at this one's got a pretzel on his head. Isn't that brilliant? We will leave links to StuffOnMyCat.com because it's of crucial importance to science to study what it's like to have stuff on your cat. Now, personally, I find it a lot more interesting to have stuff on the fish, but they never wear anything, so I don't know. What do you say, Jim? Jim said he's a pleco who's boldly gone where no pleco's gone before. What say you, Jaws? Phelps? All right, back to the sun. Here we are in 304 angstroms. You see some filamentary activity, nothing like what we saw a few days ago. In any case, thanks for tuning in. Thanks, donors, subscribers, viewers. Please don't forget to press like and to subscribe if you haven't done so already, if you enjoy our content. We'll be doing it all again tomorrow. Remember, when you're staring at the sun in 304 angstroms, don't drink. And if you drink, stare at the sun in 304 angstroms and don't drive.